Optimization using basic calculus.
Presented by two students from grade 11 AMOS by RIVERA, Ajelle, Naomi, and SALOMAG, CALIXA N.
What is basic calculus? It also fundamental principles and techniques of differential and integral calculus. It also includes concepts like limits, derivatives, and integrals. It also deals with rates of change and slope of curves. It also involves finding derivatives to represent the instantaneous rate of change of a function. It also focuses on the accumulation of quantities and the area under curve. It also serves as the foundation for advanced topics in calculus. What is optimization? It is to find maximum and minimum values under constraints. It also involves finding critical points with zero derivative. It also determines if these points are maximum, minimum, or neither using first or second derivative tests.
Let's start to solve the problem number 1. The sum of two positive numbers is 16. What are these numbers if their product is a maximum? Let x be one of the two positive numbers and let y be the other positive numbers. Let's solve the x plus y equals 16 and it will become y equals 16 minus x. Product is equal to x and y. And substitute the value of y to x times 16 minus x. X times 16 is equal to 16x. And x times negative x is equal to x squared. Let's find the first derivative. 16 minus 2x. Set the first derivative equal to 0. So 16 minus 2x is equal to 0. Negative 2x equals to negative 16. So divide the both sides by negative 2. So x is equal to positive 8. Next is to test the second derivative test. So our first derivative test is 16 minus 2x. And that will become negative 2x. Since our derivative is negative sign, that means less than the 0. So our maximum value is equal to positive 8. And let's get the value of y. Let's go back to our equation 2. Y equals 16 minus x to get the value of y. So we change the x to 8 from the first derivative. Y equals 16 minus 8. 16 minus 8 is equal to 8. So the value of x is the value of one positive number is 8 and the other one is still 8. So the two positive numbers are 8 and 8y. And the maximum value occurs when x is equal to 8.
Let's try another example. Problem number 2. You are asked to fence a rectangular region and maximize the area. You are given 400 meters of fencing materials. What should be dimension of the rectangular region?
The perimeter is 5x plus 5y. In the given or in the problem, there's a 400 meters. So P is 400 equals 5x plus 5y. Let's solve the variable. To substitute in the optimization in the formula of area, since 400 is equal to 5x and 5y, let's divide both sides by 5. And it will become 80. So 80 is equal to x plus y. And now let's get the value of y. Y is equal to 80 minus x. Let's proceed to the area. So the area of the rectangle is equal to x and y. Substitute the value of y. So x times 80 minus x. So let's simplify. X times 80 is equal to 80x. And x times negative x is equal to negative x squared. So after that, let's get the derivative. So what is the derivative of 80x minus negative x squared? So the derivative is 80 minus 5x and equate to 0. So negative 5 is equal to negative 80. So 80 minus 5x divide both sides by 5. It will become x is equal to 16. Let's test. So our first derivative is 80 minus 5x. And let's get the second derivative. That is negative 5. Since it's negative sign and less than to 0, that means the maximum value occurs when x is equal to 16. Let's get the value of y. So y is equal to 80 minus x and substitute the 16 to x. So 80 minus 16 is equal to 64. The wind is 16 meters and the length is 64 meters. That means the maximum value occurs when x is equal to 16. Thank you for watching this video.
I hope you learned something.
That wraps up our journey through basic calculus. Remember, every problem you solve brings you one step closer to mastery. Goodbye! Sir, sana po wag niyo kaming ibagsak.
Sir, kung pwede taasan niyo po yung grades namin. Maawa na po kayo.